Yo, what's going on everybody? In this video I'm going to explain the malloc function in C. Malloc is a function. It's short for memory allocation. It's a function in C that dynamically allocates a specified number of bytes in memory. Here's why you might want to use this function. The arrays that we've been creating are fixed in size. Let's say we would like to enter in some test scores, some grades. Well, to create a static array, we would say char, then an array name, we could say grades. Then we have to specify a size. For example, 5. I would like to enter in 5 grades. I have 5 test scores. Then I'll go ahead and just initialize these all to 0. So this works if we have a fixed size. Well, what if we don't know the number of elements we need until after the program is running, where a user is going to type in how many grades they have? What we're going to do is actually return a pointer from the malloc function. We will have a pointer to an array-like data structure, and that's going to be returned by the malloc function. Now with the malloc function, we have to pass in a number of bytes that we would like to reserve in memory. For example, I would like 100 bytes. I would pass in 100 here. Rather than hard coding a number, we're going to ask a user how many elements they want to enter in. Then we'll multiply it by the size of a character. Here's how we can do that. We'll create a variable of number, then a prompt. Printf, enter the number of grades. And then we'll use scanf to get some user input. We're accepting an integer. We need a format specifier of %d. Then store this at the address of our number variable. Let's say we would like to enter in 6 grades. We have 6 test scores. We're going to take our number that the user types in and multiply it by the size of what we're storing. Well, we're storing characters. We will multiply this by, use the size of function, pass in the data type of char. Now normally a char is 1 byte. If we have 6 test scores, each test score is a character. Well, this would use up 6 bytes. But if this were integers, in most systems an integer is 4 bytes. If we need 6 scores times 4, that would be 24 bytes. Basically, we're going to calculate how much size we need. How much space in memory are we going to reserve? Now, the memory that we reserve, it's from a location known as the heap. For most situations, when we use memory, it's from a place called the stack. We're going to be borrowing or renting space from the heap. This function is going to return a pointer to where that memory is located that we reserved. Now, this next part is really important. Let's say that with the malloc function, it's like we're renting an apartment. We're renting some space that doesn't belong to us. When we're done using it, we have to return the space. When we no longer need the space, we have to return the apartment back, so to say, because we're just renting it. We're going to free the space that we no longer need by calling the free function. Then pass in that pointer to our array-like data structure. Think of it like we're returning the rented space back to the operating system. But not only do we have to return the apartment, so to say, we have to reset the pointer. I like to think of pointers as a star-shaped key. They unlock a value at a memory address when you dereference them. We have a key to our rented apartment. We have to return the key too. We have to reset it. We will take our pointer of grades and set it back to be null when we're no longer using it. If we don't, this would become what is known as a dangling pointer. Avoids dangling pointers. We don't want a pointer within our program that points to memory that we're not using anymore. It's like we're returning the key to our apartment. We don't need that key anymore. When you're done renting some space, you gotta return the apartment and the key. In case this function fails for some reason, it's going to return a value of null, and we should check for that. Because if we dereference a null pointer, it's dangerous. It can cause a segmentation fault. We'll check with an if statement if the address stored within grades is equal to a value of null. If that's the case, we're going to print something. We'll say memory allocation failed. And then we'll return 1 to exit the program. The 1 serves as an exit code. That means there is a problem. Once we've made it past the if statement, that means we have some memory to work with, because grades is not null. Here we'll get some user input and store it within our array. We can use a for loop. For int I will set that equal to 0, will continue as long as I is less than the number of elements that we have. Now, previously with static arrays, we've been using the sizeOf function, something like this. Int size equals the size of our array, grades, divided by one of the elements. This is what we've done previously. However, this isn't going to work because grades, it's a pointer to an array-like data structure. What we'd be doing is getting the size of our pointer rather than the size of the array. What we'll do instead is take that user input. The user entered in how many grades they want. We'll continue this loop while I is less than the number of elements they have to enter in. Then we will increment I by 1, I++. Now we're going to use printf to create a prompt. Printf will say enter grade number, insert an integer. We're going to insert I, but during the first cycle of this loop, I is going to equal 0, and to a user, grade number 0 might not make sense. We'll add an offset of 1, I plus 1. Then we're going to use scanf. We're accepting a character. We need a format specifier of %c for a character. To remove the new line character from the input buffer, we're going to precede the format specifier with a space to ignore any white space or new line characters. Then at the address of our pointer to our grades, with the pointer to our array-like data structure, we can treat it like it's an array. We can access it by index. At the index of I, insert a value here, at this address. Then let's print our grades. For int I equals 0, continue while I is less than the number of grades we have to enter in. Then increment I by 1 each time. Then we're going to print each grade. Printf, we're displaying a character. We'll separate each with a space. I'll add a space afterwards. Then access our pointer of grades at index of I. With our pointer to our array-like data structure, we can treat it like it's a normal array. We can access it by an index. And this should work. Let's run it. Oh, one last thing. We need an import if we're using the malloc function. Standard library, stdlib.h. And I'm just going to add a colon then a space because I forgot to do that, just so it looks better. Enter the number of grades, 7. Enter grade number 1. I'll say A, B, C, D, F, A, B. And here's my grades. I have 7 grades. 1, 2, 3, 4, 5, 6, 7. Or I could pick a different number. Maybe 3 grades. A, B, C. Or maybe 10. A, B, C, D, F, A, B, C, D, F. There we go. All right, everybody, that is the malloc function. It's a function in C that dynamically allocates a specified number of bytes in memory. If you need an array and you don't know what the size is going to be, you can use the malloc function to reserve some space in the heap. But you have to be sure that you're freeing the memory when you're done with it and returning the key, setting it back to null. And well, everybody, that is the malloc function in C.